Like most subjects, graphs are used to summarize and to display data. In statistics, we use what we call histograms. This is a way to display our data. So basically, a histogram is a bar graph without any gaps between the bars, that is. And a histogram comes straight from a frequency table. And so the horizontal scale uses either class boundaries or class midpoint. And then the vertical scale will use the class frequencies. So depending on the numbers of the frequency, that will determine the height of the bars. Okay, so for example, here I have the table, frequency table. I have the histograms. Okay, you're gonna start with the first class, second class. So the first class is the first bar, reading from left to right. Okay, so first bar represent first class, second bar represent second class, third, fourth, and fifth. This histogram uses class boundaries. Okay, 0.5, 0.5, these are class boundaries. And here I have the frequency. Okay, so histograms, like I said, right, it is a bar graph, but there's no gaps in between each bar. All right, so what is the use of it? Well, see, 1, 2, 3, 4. 4 ways that we can use a histogram. Okay, so first we can see if what kind of shape that we're gonna have in terms of how the data will spread. Okay. Second, shows the location of the center of the data. Okay. Third, show the spread of the data. Fourth, identify any outliers. Now, outliers are numbers that are either too large or too small. We want to focus on the shape of the distribution of the data. Okay. So one of the way to do is to draw a curve on top of those bars. Okay. So you can see that if I draw like this, right, kind of on top of each bars, in this case, we have what we call a normal distribution because this histogram, if I draw the graph, I have a kind of bell curve shape, and that's why. And the center, that is most bars, actually most tallest bars are in the center of the entire graph. Okay. The normal distribution will be useful later because we have an entire chapter about the normal distribution. Okay, when we display a histogram, the data distribution can be skewed, and so we either going to have skew left or skew right. Okay, so this case I have skewed to the right because most of the tallest bars are on the left side of the graph. Here, most of the tallest bars are on the right, but it is skewed to the left. Okay. So skewness refer to the fact that the graph is not symmetric. Okay. Symmetric means that it is not evenly spread. So it turns out that the normal graph here will be symmetric because if I were to draw, let's say, a line like this straight. Now you can see that half on the right, half on the left. So that's why it is normal. It's not skew left or skew right. All right. Here, if I have to draw right in the middle, see, now it's no longer symmetric. All right. So if most data are on the left of the graph, we call that skewed to the right. If most data are on the right, we call that skewed to the left. So far you see normal, skew to the right, skew to the left, but together we have 4 types or 4 shapes. Okay, again you saw the normal, the bell curve, you saw the skew to the right, you also saw skew to the left. Here I have the uniform distribution. The name says uniform, just what it says. The bars are about the same size, I mean the same height. So, all right. There are also all the types of graphs that we use in stat, and one of the most, I say, useful is the stim plots. Okay. So here is an example of a stim plot. Okay. Now these numbers on the left, these are think of this guy like a stem, so stronger. This kind of like the leaf, so is not that strong. Okay, so the ones, and then these are either the tens or the hundreds. In this example, it is in the tens. So you can see that I have 40, right? So this is how you read them: 40 or 40, 42, 42. You see, and 50s, 50, 52. All right. 9, so 90, so 90, okay, 92, you see, 94, 96, and 96. The last one here is 10, so 10, 2. So 10 tens, that is 100. So 10, 2, 102, 10, 4, 104. And this is how you use a stem plot. Okay, so you can go backward and say if I have like 40s, 90s, then I can simply write the stem plot easy. Just take 4 and 9, put a bar here. So 40 will go 0, 42 will go 2, right? So you can go backward easily, okay? That's the whole point. Okay, now there are other graphs. This one's called dot plots, okay? So this is an example of a dot plots. So very similar to the stem plot, but this is kind of scale. So like 40, 41, got like 50, 50s. So okay, 60, 60, 60. So this is a bunch of dots. Each dot represents a number. Another, well, type is the bar graph, and we saw that, well, we discussed a little bit about that bar graph, right? So here, the bar graphs, this one, right? So you see that there's a gap between each bar graph. If this were a histogram, they all will be connected, okay? Another type of, well, here you can see that you can display 2 bars at a time. So but in histogram we don't display 2 bars, okay? Just the bar graph. This chart is called the Pareto chart, I guess, right? The nice thing about this graph, this chart, is that it lists the tallest, shorter, and shortest. So the bars are decreasing from left to right. Another type of graph that we use is the pie chart. Okay. Now we can also use what we call a frequency polygon. This again comes straight from a histograms, but in this case there's no bar. There's no bars, just the dots. So think of each dot represent each bar. Okay. We call that polygon. If I can do with the frequency, I can also do with the relative frequency. So okay, so without the bars, we just a dot and we connect those dots together with segments like this. We call that a polygon.